Dear students, Assalamu alaikum. We were casting cause of dispersion. Before that, we have what is dispersion of light. Now, what is the cause of dispersion? Why the white light separates or different? Why different colors deviates while passing through the puzzle? Dear students, the cause of dispersion is that the different colors suffer different deviations while passing through the prism. When they suffer different deviations, they split or they separate from one another, and which is the cause of dispersion. Now, dear students, according to Cauchy, there's a scientist whose name is, according to Cauchy's refractive index, according to Cauchy's formula. N is the refractive index. It is equal to A plus B divided by lambda square plus divided, where A and B are constants and lambda is the wavelength of light. Now, dear students, according to Cauchy's formula, refractive index is equal to A plus B by lambda square, where A and B are constant and lambda is the wavelength of the light. Now, what we obtain or what we conclude from this end, according to this relation, the refractive index of the medium or the material depends upon the wavelength of the light incident on that material. According to this equation, or what we conclude from this relation confirms that the refractive index of a material or medium depends upon the wavelength of the light incident on it. That is, this refractive index is inversely proportional to the square of the wavelength. We will write it here. Refractive index N depends of a medium or material depends on the wavelength of the light incident on it. That is, refractive index is inversely proportional to the square of the wavelength. According to Cauchy, this refractive index is inversely proportional to the square of the wavelength. That means the refractive index of a material or medium depends upon the wavelength of the light which is incident on the material or which is incident on the medium. Now, dear students, different colors have different wavelengths. Here, and inversely proportional to the square. Different colors or different lights have different wavelength. Now, dear students, as we know, the wavelength of the red color is maximum and that of violet color is minimum. That means we are, in other words, we can say the wavelength of red color is greater than the wavelength of the violet color. That is, therefore, we will write it. Wavelength of red color is greater than the wavelength of the violet color. As you know, different colors have different wavelengths. That means this red color has the most wavelength or maximum wavelength, and violet has the minimum wavelength. Or in other words, we can say the wavelength of red color is greater than the wavelength of the violet color. Now, according to this, the refractive index N or the material of the prism for red color is minimum and for violet color is maximum. I will repeat it. The refractive index N or the material of the prism for red color is less than that for the violet color. That is N or is less. That means the refractive index or the material of the prism is less for red color and is more or most for the violet color. Now for small angular prism we have delta is equal to n minus 1 to a. Therefore delta r is equal to n r minus 1 into a, and delta v is equal to n v minus 1 into a. Hence delta r is, what does it mean? Delta r is less than delta v. This means that the deviation of the red color is minimum and the deviation of the violet color is maximum. That means while passing through the prism, the red color deviates less, whereas the violet color deviates more. According to this equation, the deviation for the red color is less than the deviation for the violet color. Or in other words, we can say that the red color deviates less and the violet color deviates more while passing through the prism. Oh. This shows that the red color deviates less and the violet color deviates most while passing through the prism. That is, according to this equation, or what we conclude from this equation, the deviation of red color is less than the deviation of the violet color. Or we can say while passing through the prism, the red color deviates less and the violet color the most. And this is the reason that when we see in the spectrum, the red color is at the top and the violet color is at the bottom of the spectrum. Why? According to this equation, because the red color deviates less and the violet color deviates more. That means this is the cause why the red color is seen at the top of the spectrum, visual spectrum, and violet color is seen at the bottom of the spectrum. This is the reason for the red color at the top and violet color at the bottom of visible spectrum when white light passes through the prism and that means this is the reason why the red color is seen at the top of the spectrum and violet color at the bottom of the spectrum. The reason for this is that the deviation for the red color is least and the deviation for the violet color is most when the white light passes through the prism. This is the cause of the prism, dear students. Thank you.